In this class, we will refer to measures of dispersion. We are also referring to what? Measures of variations. And under these measures of variation, we have some features which include the range. We have the range. We have the mean deviation. We have the this range concerns both the quartile range, interquartile range, all of those. Anything concerning range, interquartile range, semi-interquartile range, all of them fall under the range. This is deviation. Now, under deviation, we can talk about the mean deviation and the standard deviation. The standard deviation and the mean deviation. Now, we then have the what? The variance also. The variance. All these things, all these are what? Under what? The measures of dispersion. In our previous class, we have treated the interquartile and semi-interquartile range, or you can call it the quartile deviation. We have treated them. So this, we'll be looking at what? The standard deviation, the mean deviation, and the variance. The range, remember, the range is the difference between the highest and lowest data. Now, if you are given something like this and you say you should find the range of the table below, you see that the highest of frequency is this one and the lowest is this one. So we now say that the range is equal to what? The maximum score is what? 30 minus what? The lowest score, which is what? 1. So the range is what? 35 minus what? 35 minus 1 to give us what? 24. So this frequency is not about what the subtraction frequencies. No. If you decide to open up this, it means that what 1 to 5 is just like 2 in number. 6 to 10 is just like 5 in number. So for you to now get the range, you take the maximum of here is what? 25, and the minimum of here is what? 1. So the range of this type of data, this is a group data, is what? 24, 25 minus 1 to give us 24. When we talk about mean deviation, we mean the arithmetic mean of all absolute deviations from the mean. What does it mean? Say this is the arithmetic mean of all absolute deviations from the mean. In this case, you first of all calculate what? The mean. Now, when you get the mean, you start getting the deviations of every element of every of the what? Data or mark from the mean. Now, this is the deviation. That's that element minus mean. Now, whatever you get, you take the absolute value of it. Getting the absolute value of it gives you a positive what? A positive value. Now, when you sum all of them, divided by the what? The number of this data, we now have that this is the mean deviation. This is what? Mean deviation. Now, in our example, you are giving a question like this. Example. Find the mean deviation. Find the mean deviation of the following. You are giving something like 2, 7, 6, 5, 9, and 7. You have to find the mean deviation of this. Now, what do we do? First of all, you have to find the mean. What is the mean? Mean is when you sum all these things together, 2 plus 7 plus 6 plus 5 plus 9 plus 7. All over the total number 1, 2, 3, 4, 5, 6. So what do you now have? This is 9, 18, 18 plus that's 39, 29 plus this one gives us what? 36 over 6 to give us 6. Do you understand?
Yes.
Now, having noted the mean, which is 6, the mean is 6. Now, let's just take the deviation from the mean. Now, let's just put it in tabular form. This is the x. This is x minus x bar. This is s minus s bar. Now, this is the absolute value of s minus s bar. Now, the first one we have is 2, let's say 2, 5, 6, 7, 7, 9. We have noted our mean. Mean is what? 6. Mean is 6. Now, let us take 2 minus 6 is what? Minus 4. Minus 1, 0, 1, 1, 3. Mean deviation will be absolute value of positive, 0, 1, 1, 3. Now, the summation. The summation of this gives us what? 5, 5, this is what? 10. Now, the mean deviation will now give us what? 10 over what? 6. Now, this 10 over 6 gives us something like 5 over what? 3, which is what? 1 whole number, 2 over 3. So this is the mean deviation. Now, the third question has been added. Also work on it. Remember that this thing you are solving for is the mean deviation for ungrouped data. This is not a group data. So you can find mean deviations for group data also, but at this time we are working on mean deviation for ungrouped data. One, you'll be given frequency.
No.
Find the mean deviation
I
for
don't
the data
understand that
in
number
the table
4.
below. Okay, no problem. We will do it. Max 10, 12, 13, 14, 15, and 16 with corresponding frequencies 9, 2, 3, 6, 3, and 2. So we have to find the mean deviation. Remember, this is the mean deviations involving frequencies. In this case, we have x, f, fx, s minus s bar. We have what? S minus s bar absolute value. We have what? F s minus s bar. Look at the items we have on our board now. We have x, f, the frequency. This one now goes with what? What we have here. This is 10, 9, 12, 2, 13, 3, 14, 6, 15, 3, and 16, 2. Now, fs means what? This times this gives us, this times gives us, this times gives us. Now, remember, you are also expected to what? Add sum your frequencies. 9 plus 2 is 11, plus this is 14, 20, 25. This is summation f. Having gotten our fs by multiplying this to this, you sum this in to give us this. And here, we know that mean is essential as summation fs over summation f. What do we have? Sum of this, which is 314 all over 25. Now, what will it be when you divide it by 25? We're going to get 12.56 as our mean. You can approximate this into 12.6 to make the work easier. We now approximate to 12.6. Now, we are going to now get the deviation of each of these elements from each of these elements from what? 12.6. Oh yeah, it should be 10 minus 12.6 to give us something like what? Minus 2.6. The absolute value of this will be 2.6, 0.6, 0.4, 1.4, 2.4, 3.4. You are going to now multiply this one, the frequency, times this to give us f times the deviation. This one is what we call the deviation. You can get the short form as well. The deviation. This is the absolute deviation. This is the deviation. Now this one will now be what? FD. To shorten it, we have it as FD. Having gotten this, we now sum this thing. The summation of frequency and deviation. Remember that this is its absolute value. Give us what? Sum this thing.
Okay.
The summation of this gives us. We now have that our mean deviation, the mean deviation, S bar deviation, will now be the summation of F. Let's write it boldly. The mean deviation will now be summation F of the deviation all over summation F. So what we now have is what? 48.2 divided by summation of frequency, which is 25. So
1.928.
Good. 48.2. Good. 1.928. You can approximate to 1 decimal place to be 1.9. So this is our value for the mean deviation involving frequencies, or with the use of frequencies. I'll give you an example, solve it, and send in your answer. So this exercise in getting the standard deviation, we say that what? This is a measure of dispersion that is obtained. This is obtained by computing the root mean square, or computing or calculating the root mean square of what? Of the deviation from the mean. Now, what does it mean? If you have this now, see, the square of this deviation is this thing. Now, the summation of it, when you now get the root of it, from what? Or let's say just bring this thing down all over what? N. This is what we call the standard deviation. Or some people can say it is X. So this is the standard deviation. Or when we talk about the one involving frequency, you can say it is what? Summation F of this, all the summation F, not take the root. That is what we mean by that. Find the standard deviation for the data below. If you give it this, now this is 2. Now remember, in solving this thing now, we have that what? We have our X, we have the deviation, we have our deviation, absolute deviation. Now, let's just make this one the absolute deviation. This one is this. Now, let us have this. Since we don't have anything like F, let's just make it like this. But remember that what we're supposed to have absolute ordinary deviation. Okay, since we are talking about group data without frequency, let's just have something like this here. Let's have it this way. Now, we have starting from the list 2, 5, 5. Okay, you can write the 5 twice, as case may be. 2, 5, 5, 5, 6, 10, 12, 14, 18. Now, what is the mean of this? Get the mean, sum this thing divided by the number 1, 2, 3, 4, 5, 6, 7, 8. So sum them and divide by the number. What will be our mean? Remember, the mean of this thing is 9. Deviation will be what? Minus what? 7, minus 4, minus 4. Remember, we decided to split this thing. Minus 3, 1, 3, 5, and 9.
9.
Now, remember, when you sum the deviations, it must give you what? 0. So what's the absolute deviation here? We have what?
7, 4, 4, 3, 1,
3, 5, and
9.
Now, you can easily get the mean deviation when you sum this thing and divide by 9. Do you get it? That is the mean deviation. When you sum this particular one by 9, get the mean deviation. Now, square this particular one, you have what?
49, 16, 9, 1, 9, 25, 81.
Now, summation here is what? Sum is what? Sum that apart and you get your value. Now we have gotten our sum to be 2064. Summation of this.
Uncle.
Yes.
Have they already squared? Have they squared the last this thing?
Yes, square this thing, square each of these elements and give you this. So summation of this gives us this. So we now have that what? When you finish with that, so let us now go to the other side of the board and complete our work. We have that the standard deviation is summation of the square of the deviation, sum of deviations all over what, and take the root of it. So which gives us what? 206 divided by what? 9. This 1, 2, 3, 4, 5, 6, 7, 8. Oh, there are 8 to count back. 1, 2, 3, 4, 5, 6, 7, 8, 8. Good. So which gives us what? Root of what? 25.75. So
to 5.07.
So this is now the standard deviation. Remember that what? Variance. Variance is given as this or this. Means that at this point, When you remove this thing, this particular 25.75 is a variance. Why the root of it is the what? Standard deviation. Remember we said that the variance is this one, the 25.75. Why the root of it is this one? So remember this is totally different. It's not part of
Uncle,
it.
please.
Now it says find the standard deviation of the data. Remember we are still on group data. So this is an group data. You have to find the standard deviation. So what you need to do is just to find, first of all, get the mean. Now, the mean of this without our table is just to sum everything here. We have 15 plus 16 plus 11 plus 15 plus 14 plus 20 plus 17 plus 25 all over what? 1, 2, 3, 4, 5, 6, 7, 8. So we now have the mean to be what? This is 31, 41, 42. 42 plus this one gives us 68. 68 plus what? This gives us what?
88.
82. 102 plus what? 25 and 17.
119.
Good. So we have 119. Confirm. Another person should confirm it. All over 8. What do we have?
No. As in,
you see, it's not correct.
No, it's not correct. I've not added the 25.
Okay. So we now have what? The sum of this is 119 plus 6 for 4 divided by 8. This gives us what? 1 remaining 6, 18. Now, this is the mean. This is the mean. Now let us now get the deviation from each of these sorts data. Good. We have here is what? Minus, since our mean is 18. So here
minus 7.
What? 7.
7.
Minus 4.
Minus 4.
Minus 2.
3.
Minus 1. 2. 7 and what? 8.
7.
Now remember, when you sum this thing, gives us 0. This 8 goes with this and this. 2 goes with minus 2. And 7 goes with this one. Now we have the absolute values of this 7, 4, 8, 2, 1, 2, 7, and 8. Now, for mean deviation, you add this thing. You can get the mean deviation. You can add this thing and get your value. The square of this is 49, 16, 9, 4, 1, 4, 49, and 1, 64. You also sum it and get the value. Now, we have seen the summation of this gives us this. Is okay, 196. Now, remember, we are not going to get their what? Their mean deviation and standard deviation respectively. Now, this is what? 34 divided by number 1, 2, 3, 4, 5, 6, 7, 8. Right? This is 8. So what we have is what? 4.125. Now, the standard deviation, we say S or is equal to what? The root of summation S minus S bar all square all over N. Now, what we have here is 196 all over what? 8. You take the root. Now, 196 divided by 8 gives us what?
24.5.
24.5. When you take the root of 24.5, we have what? We have 7 root 2 over 2, or you can say it is what? 4.3, 9.
4.9.
95.
4.9.
95. Okay, 9. Okay, let's just take it to one. This is 4.
Uncle, can we say it's 5.0?
Let's just take it that way. 4.9. This is now the standard deviation. Remember, we said that the variance is the square of the standard deviation, which means it is 24.5.
24.5.
Good. You have gotten this one, you have gotten this one. You can easily get the variance. The variance is what? The square of this one, which is what? 24.5. So take note that what? You can get both standard deviation, variance, and mean deviation from one table. That's by the way. We are going to give you a question or some questions, solve and send answers to us. We thank you so much. Now, look at this, just solve this thing and send. I want to give this other formula for standard deviation in case you want to take them out. You are free to check them out. You can use them to confirm your answers when you are done. These other formulas of standard deviation. Take this thing down, solve and send in your answers. In summary, we say that what you can use this as formula for solving or finding the standard deviation. Or when it's been splitted, you can also use this as a formula for solving standard deviation. Please, I would like you to go and confirm these two answers. Once you get work on this side and also work on this to know if both give you the same result. We thank you for being part of today's class. God bless you. Do join us next time. Thank you.